Hi everyone. Today we're going to be doing a quick lesson on the sine and cosine rule. So I've got a scalene triangle here, A, B, C. The opposite side to the points, so the points are named with capital letters, and the opposite side to point A is length little a. Opposite to B is length little b, that's all the way along the base here, and this side is length C. Now I've put in a perpendicular height here, h, and then I've noted that from this point D to A is x, so this part over here must be b minus x. Now to begin with, let's just work out the area of the triangle. So we all know the area of a triangle is 1/2 of the base multiplied by the height, and from the angle alpha here, and I'm trying to find a replacement for h, I would use the sine ratio. Sine of alpha is h over c, so h would be c multiplied by the sine of alpha. That's a very straightforward application of sine. Now here's where it starts to get a bit interesting. I make a note that side B and C are really just any two sides of the triangle. There was nothing special about side B and C. And angle alpha, well, that didn't work very nicely, did it? Try that again. Angle alpha is the included angle. Now by that, I mean it's the angle between side B and C. There was nothing special about side B and C and angle alpha. This is a scalene triangle. So side B and side C happen to have angle alpha as the included angle. But I could have written the area of the triangle as 1/2. Let's imagine I went side A and side C, A times C, and the included angle there would have been the sine of angle beta. Likewise, I could have chosen to do the others. Now, which ones haven't I picked yet? I've got B, C, A, C, so I could have had A and B as the sides, and the included angle there is gamma. We have three different but equally good expressions for the area of the triangle. Now obviously they all have to be the same, so let's write that out, all three of those. If I had 1/2 B, C, sine alpha, that would equal 1/2 A, C, sine of beta, which would equal 1/2 A, B, sine of gamma. Now immediately we'd notice that we could cancel the factor of 1/2. Now what if we divide everything by the term ABC? So B and C cancel there, A and C cancel from the middle part, A and B cancel from the piece at the end. And this gives us the sine rule. The sine of angle alpha divided by side A equals the sine of angle beta divided by side B equals the sine of angle gamma divided by sine C, side C. That is a very handy rule, and it applies to any scalene triangle. It doesn't have to be a right angle triangle anymore. So this is known as the sine rule. How interesting. Now there is another interesting rule that we can develop from this diagram. So I'll make a note here that we have two right triangles edge to edge, and if I apply the Pythagorean theorem to this first one, I would have h squared plus x squared equaled c squared. I'll just put that down. H squared plus x squared equaled c squared. And from that it should be pretty clear that h squared is c squared take x squared. We'll need that in a minute. Then looking at the other right triangle here on the left, I would have h squared. Now I have b minus x all squared equals a squared. So let's write that down. A squared equaled, it was b minus x squared plus h squared. Now this is where I need my replacement for h squared. So let's keep going. Expanding this, I'd have b squared take 2 times b times x plus x squared. Then h squared I'll replace with c squared take x squared. We can see that plus and minus of the same thing disappear. Writing this once more, I've got b squared plus c squared minus 2 times b, and I still have this x sitting here. Let's go back and take a closer look at x. So x is the base of this smaller right triangle. I have angle alpha and I have hypotenuse c. So x is an adjacent side. Cosine of alpha would equal x over c. X should equal c cosine alpha. Let's replace that. X should equal c cosine of alpha. And that is the cosine rule. So write that down here. Cosine rule. Now there's nothing special about the order in which I wrote these. A just happened to be one of the edges of the scalene triangle. B and C are the other two. Notice that B and C are repeated here. But again, this angle alpha is the included angle. It's the angle between B and C. If I just go back up and check that. So there's angle alpha in the corner. There's edge B all the way along the bottom, and there's edge C. So as long as the angle is between the two sides, your cosine rule is going to be true. So we could write this in, if B was the subject, B squared, the other two sides must be A squared plus C squared minus, and it's these two again, A, C, and now what's the angle between A and C? It's beta. Alternately, we could start with C squared would equal A squared plus B squared. A and B are repeated here, 2AB. And what's the angle between A and B? It was gamma. So all three of those are equivalent, and which one you write really depends on what information you've been given to work with. So there's a very brief recap of the sine rule and the cosine rule. Those two rules, along with this one up here about the area of the triangle, those are very handy in finding or solving any scalene triangle. And to solve a triangle, it means to find all three angles, alpha, beta, gamma, and all three edges A, B, and C. That's enough for now. See you in the next video.